Hey, fifth grade. I miss you. I'm already counting down the days till we can be back in the classroom together, doing estimation station and all the fun things that we love to do. I don't want this video to get too long. It's already probably gonna be, and so I'm gonna just skip right to it. But couple things. I hope that you are taking full advantage of these few weeks being at home with your family. I hope you're having a great time. I hope that you are doing your work cheerfully and submissively and with excellence. These packets are, I've poured over them. Every assignment is thoughtful, and I hope you're doing your very best at home. Also, this is such a great time to learn a new skill. Learn something you've always wanted to try, or work on your art skills, work on your dribbling skills if you're into basketball. I'm learning a new pattern, and I like to knit dishcloths, and I've taught myself a new pattern. Isn't that cute? So take advantage of what these few weeks allow. Caleb and Noah are wanting to get better at their guitar, and so pick a skill. I can't wait to hear what you've chosen. Maybe it's a language. Annie's working on sign language. Just take full advantage of it. Okay? So this is a math lesson, and this is for lessons problem sets 108 and 109. You are going to teach yourself lesson 110. I think you can. It's on symmetry. Read over the lesson. Look over the practice problems. And then you're going to do all of the problem set lesson 110. Okay, I'm going to plug in Dobby, and we're going to get started. You need your math book, and you need paper and pencil, maybe close by at least, and turn to problem set 108 while I get Dobby going, okay? All right, bye. Okay, these lessons are about triangles. I'm going to kind of go quick because, again, I don't want this video to get super duper long. Okay, we're going to learn some new words. And one of the words is, these are geometry words, congruent. The word congruent. That means a shape. Two shapes are the same size and shape. So pretty much exactly the same. If the triangles are congruent, that means they're the same size and same shape. We're going to talk about a different definition later that doesn't have both. It just has one. But congruent triangles are the same size and same shape. Now, one way we can find that out is if we were to put these triangles right on top of each other, we could determine if they are indeed congruent, if they are indeed the same size and same shape. And you can see that these are, but I'm going to put these back. Now, in order for me to figure out if these triangles are the same size and same shape, I have to perform some steps. Some transformations is what they're called. The first transformation I'm going to tell you about is a word called rotation. That is something you are probably familiar with. It doesn't sound too weird. The other one is translation. And the last one we're going to talk about is reflection. I love these words. Within them hold some clues to what we do, what they mean. So we're going to first start with the word rotation. The clue inside the word rotation that I like to use is this T right here, this t. Rotation. It means turn. We're just going to turn the triangle to match the other one. The next transformation I'm going to teach you is called translation. Translation is just, watch, you ready? All I did was slide. And look right inside the word translation is this S and L, and that reminds us to slide. The last transformation I'm going to teach you is, watch this guy. It's like he's on a diving board and he's flipping. I'm going to flip him this way. He's flipping. So we just used the step or the transformation called reflection. Reflection inside the word reflection has an F and an L, and that reminds us we're going to flip the shape. Okay, so that takes a shape, a triangle that's the same size and shape. We do some steps to turn it, to slide it, to flip it, to determine if the triangle is indeed congruent. The thing about congruent triangles is they have not only are they the same size and shape, but their angles are the same and their length of sides measure the same. So when you get them kind of going in the same direction, then you can determine that this angle and this angle are going to be the same, and this angle and this angle, and this angle and this angle are going to be the same. And that's going to lead me to lesson 109. When I'm done with this lesson, I want you to go back and look over the practice problems for lesson 108. I'm going to take you through the practice problems in 109. Okay, stay with me, you're doing good. So when we look at these congruent triangles, we can determine that the angles correspond. That's the word we're going to use. That's our mathematician word, correspond with one another. So I'm going to flip these over. You can see these letters here. I've got triangle ABC and triangle X, Y, and Z. But how do I know which angles correspond with which angles? Well, first I've got to use some transformations. I'm going to take this yellow triangle, I'm going to rotate it, I'm going to translate it by sliding it over. And now, I know my letters are going the wrong way, but I think you can figure it out. That angle A and angle Z correspond to one another, and I'll explain exactly what that means in just a minute. Angle B and angle X correspond, and angle C and angle Y correspond. That is also kind of a fancy word for saying that the angle of A is the same as angle Z. The angle B is the same as angle X, and angle C is the same as angle Y. This is also the same for lines. The measurements are the same. So you take these two congruent triangles, and if I said that this line was 6 and this line is 4, and we know that these triangles are congruent, how could I figure out the perimeter? Let's say this line over here is 4 also. So I have some missing information on one of the triangles. But information I do have is that they're congruent, so we know that the line measurements are the same. So first we have to figure out which lines correspond with what, and I'm going with which, the lines from this triangle correspond to the lines from this one. So I'm going to do a little translation, or actually rotation. I'm going to turn this one a little bit. So now they're in the same position. This one's 4, so that one's 4. If this one's 4, then that one's 4. And this long guy we've determined is 6, so we can determine that this one's 6. So if I was figuring out the perimeter of these triangles, I would add up the lines, just like we always do when we're doing perimeter. Our unit of measurement is inches, so we would take 4 plus 4 plus 6. Okay? The next thing I want to talk to you about is triangles that are similar. And I'm going to just have to use the book for this. Let's look at these triangles. This is on page 527. We have triangle 1, 2, 3, and 4. The definition of a similar shape is that they are the same shape, but not the same size. Not necessarily the same size. So we can see that angle 1 and 2 are the same size and shape. So yes, these guys are congruent, but they're also similar to each other. Let's look at angle 3 and 2. These look pretty much the same shape, but definitely not the same size. Angle 3 is bigger, and so it's the same shape and not the same size. So we say that these triangles are similar. Triangle 4, he's just the oddball. There's nothing similar about him except there are 3 sides, but other than that, he doesn't match up to these other guys at all. So if you read through this whole paragraph, what you would find out is that triangle 1 and 2 are similar and congruent. The triangles 1 and 3 and 2 and 3 are just similar. They're not congruent because they're not the same size. They're just the same shape. So you can see that they all three have 90-degree angles. So they're the same shape, but not the same size. That means they're similar. The other neat thing about similar triangles is that their angles correspond to each other. Even though they're not the same size, because they're the same shape, their angles correspond to one another. So if you look at this triangle and this triangle, once we get them in the right positions by rotating and reflecting, so by turning and flipping, we've got them in the same position. We can see that our 90-degree angle corresponds with our 90-degree angle. We see that this corner right here corresponds with this corner, so we determine that that is 60 degrees. And we could determine that angle A corresponds with this angle, and so angle A is 30 degrees. Now we can only do that if we know that our triangles are similar, or that we know if our shape is similar. If it doesn't say it in the problem, or you don't have any way of knowing, you have to determine that they're not similar or they're not congruent. So you're looking at the information that your problems in the problem set give you. Quick question, I'm going to ask you a couple true or false. Listen carefully, are all squares similar? They all have 4 sides, they all have 90-degree angles. Yes, they're similar. They may not be the same size, but they're the same shape because a square is a square. Good. True or false? All similar triangles are congruent. So if we said that these 2 triangles are similar, are they congruent? No, they're not the same size and shape, but they are just the same shape. So that's false. If 2 polygons are similar, then their corresponding angles are equal in measure. True or false? True. Similar shapes, similar polygons have corresponding angles. That means that their angles match one another, that they're equal to. Go ahead and look at the practice problems D and E and see if you can answer those on your own. And I told you before, I want you to read lesson 110 on your own. If you need to go back and watch this video again or go back and read through lesson 108 and 109, do that. Read through all of lesson 110 on symmetry, and then you're going to do problem set 110, the whole thing, because y'all are awesome. And I hope this helps. I love you, and carry on with good schoolwork. Bye, friends.